Hello. All right. We can review the third time, huh? All right. So we talk about the midterm review, but what we gonna do? I'm sure tomorrow I'll record this one more time. So midterm review for CSC200. Yeah. So the topic, pretty much, let's make it real quick. That we want to go to midterm tab, right? And I want you to do three things here, right? First, look at the topic. And the topic is pretty much showing you what you need to review right here, right? And second, review the exam. Exam pretty much is practice question sets, right? It's gonna look like that. So you only want to do the first and second between chapter 1 to 4, okay? Now, if you have time, you can start 5 a little bit. 5 is actually talk about the method. In the midterm, maybe there's some few questions that talk about method. That's why I start to showing you in here, right? I start to write program, show you how to use the method. We'll come back to this, but the third thing that you want to do, print out the ASCII table and bring it to the test, okay? Now, let's talk about the topic of, on the test for exam, don't rely on the key, okay? Study and bring in the questions. Key, not always correct, okay? If you get the wrong key, you cannot open your house. Same thing here. Don't rely on it. Make your own key and bring the questions. So we were talking about math class. Math pretty much generate the random numbers, right? So we try to create a method named tally. The reason we want to do this, so let's rewind this a little bit, right? Alright, so let's rewind this. So we are creating a math.random to generate the number to return between 1 to 6, and this will be taken care, right? Because math.random returns what? Number between 0, 0.0 and 1. When you times 10, it's going to return 0 to 9. And when you do cast to int, I mean, it could be 0 0.0, 0 point whatever to 0 to 9 point something. But when we cast, it's always going to get a whole number, which is 0 to 9. Cast to int. And then we mod 6. When we mod 6, it's pretty much just, if you look at, we look at the remainders, right? 1 mod 6, you get 1. 0 mod 6 is 0. We know that return between 0 to 9. So these are the remainder it's going to get once you do the mod, right? Like for example, 9 mod 6 is pretty much have 6, right? Then 9 minus 6, like 6, 1, 6, and 9 minus 6 is 3. So you're going to get that. So it's pretty much guaranteed that it's going to be between 0 to 5. Then that's why we add 1 to it. Let's get 1 to 6. We want to create an application for dice, right? Now we said, okay, we're going to count, we're going to run it a million times, just like you're rolling the dice for a million times. We want to see the probability that we're going to get number 1, 2, 3, 4, 5, 6. We just make it in an array to count. Case 1 to 6. And we print it out. So once we do that, we print it out, we just multiply. We try to, in percentage, right? Divide by the limit, which is the million times, and multiply by 100. So we see the distribution. Yeah, showing that most likely only 1 and 4 that are about the same, 20%, and 5 and 6 about 10%, right? So it looks like it's not like distributed evenly, so this is not a fair game. I'm probably going to lose more if I bet on 5 and 6, right? 4 million times, correct? Then how about I want to use random class? In Java we have random class. So like if I use random class, I'm probably going to have to do the same to keep tracking on the count. So when you have to use the same thing over and over again, then we better create a method. So we learned one method named main so far. So we could create a method like we're going to probably want to do this whole thing one more time, right? And print the result out. So that means I'm just going to call like the method like tally, like to do tally, right? So in that case, you probably want to create a method public static void, the same like main, but instead of main I call tally, right? I probably put the same code in there because it's going to do the same thing. But I just need to clean up a little bit, like all the declaration values here. Like limit is supposed to be shared, right? Count values. Then if it's going to be shared, then I'm probably going to make it the scope, right? So if you look at the scope, before it's only valid inside the curly braces when the limit is inside the tally. That's why they were, if I undo again, right? So this limit only valid in this scope. We call local variables to this tally. That's why it's red here, because we do not know what it is outside of tally, same as count value. So if I want to make it like global but local to the class, then I just put it in a class level. So it's going to be valid between this class curly braces. But yeah, since it has statics, I need to make it statics variables. Okay. Alright, so next step is if you read the code, this one is based on math.random. So the value here pretty much just being initialized right here. What I can do, I can actually pass this value right through the parameter. So I move this in value to that location instead. Right, so this whole thing can be passed and equals to value, right? That's one way, right? And then you don't really need to end the statement. That's probably going to do the same thing when you run, like what we have before. Alright, so let's see why it's always 5. Maybe right there, right? So what we can do, I'm going to make this outside. I can declare it local again, right? Then we're not confusing about parentheses. So we can pass the value in. The same thing here, right? This value just local to this curly braces, and this value local to the other curly braces. So let's try again. Alright, so it's always giving you 100. So let's see what caused that. it's always giving you 4 in this case, right? After we change, switch the value. Oh, is it because of this? 1 second. No, this is increment limit. So what we're gonna do, we're gonna print out the value, then we see what is going on here. Always passing in 6, huh? So it's always have 6 in. So that means this is always generating 6. So math.random giving you what?
Yeah, because you only did math.random once. It's outside of the loop.
Oh.
You're not looping that value. You just get that value once.
That is correct.
Past that.
Because we only do it once. So now we want to actually loop this. Then we cannot pass this way then. So what we're gonna do, we're gonna put this back. We'll put this back first. That's in a loop now, right? Then let's try again. This should do what we need first. There you go. Alright, so we have, now we want to replace this with math.random. Let me just use math.random for now first. This is an easy way first before we can actually pass in. So math.random is for the random in math class, but we have a class named random. So if you want to use random class, let me just create it outside and share in there. So you have to import from java.util.random. And then you can do just like rand.nextInt, just like when you use scanner. So if you want to do between, now let's read what is nextInt giving you first. This has to be static, right? So first we need to know what is the nextInt giving you. Is it between 0 and 1? Or, right? What? We can look at the random Java doc. So you're gonna go to nextInt, returns int value form. But what I want the parameters. Int value between 0 inclusive to the specified value exclusive. Specified value is the n here. But not including it, right? Meaning the same thing, right? We want 0 to 5 and then plus 1. There's going to be 1 to 6, right? Then we can do switch case again. The key is we want to see if it's distributed evenly. Oh, it's not including 5, have to be 6, right? Because exclusive, right? So this one will be evenly. That's how we use it. Okay. Now, I think that's another way to test between this. I don't want to. You could actually pass ran as the parameter and mat.random. Like now, I don't want to cover that yet. Okay. To handle like tally can support different objects.
Why would you choose math.random over random class? Is there any benefit, or are they just two ways to do the same thing?
It's just random class pretty much make it easier than like we were thinking about how you do evenly, right? With random, so we better use random in that case. But math pretty much one of your function that people normally use in your calculator, get random number, because this is represent a calculator, that button. Sometimes you want to get random number to use. Okay. So that's pretty much just the review on math class section, right? But for your test, you can have 30 questions. They are 100 points. You want to review the radix conversion between different base number, decimal, binary, and hexadecimal, and vice versa. Review the method of the strings. Now, math class we just show you, right? Like, don't forget to look at those other methods: square root, random, string is value of. And you can just pretty much review this code too, because the test pretty much is going to ask you what's the output of each of this. And we just show you about the methods. So you should know some of the methods which in class exercise 5.1 we didn't reach to that yet, but I want to show you that you might want to go and review that section when we talk about the method. Like for example, if I want to print hello, I could replace this with the statement system.out.print hello, right? But by calling the method, so you pretty much just make the method to say hello, right? So if I want to say hello 2 times, I just call the x method 2 times, something like that. So it's going to call hello 2 times. Yeah, if it's given, then it's going to say hello Nick, right? Or you can provide any other name. So it's just like the math dot, right? Random dot next or next int with no parameter and with parameter, right? Or sometimes you see the method that you create. Sometimes you could provide parameters. Sometimes you don't have to provide, right? Like this one, make it simple, like print hello David, right? So using method make it simple when you try to repeat something over and over again with the method. Just like loop, right? Loop, you try to repeat something over and over again. You can use loop too, right? So in loop we call iterations. By using method called self over and over again, we call recursion. It can technically do the same thing. Give the same repeating statement over and over again. So we have to review loop, do while, and then while and for, right? We have to know the difference between this, right? Do at least once, right? And then evaluate the expressions. And we have the break keywords and continue keywords, right? Yeah, we did break already when we talk about switch case. And it doesn't have to use in switch case, it can use in the loop too. Once it breaks, it's going to exit the loop right away.
I remember reading that you're not supposed
But it's not a good way to do. To exit, right? The loop. No, it's not a good way to do. So we have continue. Like, what's the difference? Break pretty much just exit. Continue pretty much just you want to make it keep going. Like instead of, let's look at this code, right? This is for loop, right? While loop right here. So let's read this code. X equal to 0 while x less than 0. Probably it's not going to do this, right? So let's say -1. So it's going to do this and increment x to 1, which is it's going to be 0, right? -1 plus 1. It's going to print and say if x less than 9. Less than 9, probably it's going to be true, right? Then it's going to continue. Alright. So it prints 0 from this. And it's going to continue. Now the question for the test is going to be what's the value of x at this point? X is going to be what? 0, or actually -9. You see, it's not -9. If it's -9, it's going to do this again. Because of continue, make it go back to the beginning. And if it's 0, that's why it's exit, right? It never do the next statement with the continuous statement. Like, if I don't have this section, let's say if I don't have continue, right? See, it's always going to be negative because it keeps subtracting more and more and more, right? But continue make it exit the loop, right? Continue mean I continue back to the beginning, right? Which x is 0, that's why it's exit, right? It didn't make it exit the loop. For example, if I say it's because of the condition, right? So now, how about this? X equal to 0. What's the x now? 0, right? If x greater than or equal to 0, but it's still exit because of this, huh? It's not about this. We technically don't need to do yeah, let's just test that, right? Yeah, it's going to say unreachable because continue make it go back right there. Never reach this line. Make sense? Like if I change the condition here a little bit, less than 10 maybe, it's going to show the difference, right? It's not break yet. Break just exit right away. Like this one is still going to do the expression, correct? See that? So it's going to do as long as do less than 10, but it never get into that because of continue. Okay, but if you do break, it will be different, right? Break will, yeah, it's going to exit the loop right away. See that? So that's the difference between break and continue. Any questions?
Couldn't you just omit either of those statements and just run the loop and do it itself? So instead of continue, just get rid of continue in that last line. So just move the further brace. If you just got rid of the if and continue, wouldn't it exit the loop once it got to 10 anyways? Like wouldn't it do the same thing without?
How could you exit the loop if you don't have this?
Because it only runs while x is less than 10. So as soon as it gets to 10, it stops itself. Yeah, it would still work because you have all the pieces.
Oh, I see.
Already above the if statement. It's just we're wondering why you have this if continue statement at all.
Oh, I mean, it depends on the situation, right? Like in this situation it looks like that, but sometimes, like if something happened to be true, you don't want to evaluate the following statement. See that? But if it's not true, then you evaluate. Like actually, like what happened if actually this still work? Look, in this case I need this, but it's gonna skip to that, right? That makes sense? Then you cannot eliminating this in this condition. Like maybe I said when it's negative I want to do the else, right? When it's positive I don't want it to do the else, or like there's another way to make the logic, right? Then continue still be able to help, right?
So after you run this, it gets up to x equals 10, and then it stops. It doesn't continue anymore, and then x is equal to 1 after that. It runs that second statement. So after, if you press run, it would print it, but x would be equal to 1, right?
So it's gonna be 100 minus, let's see, let's run first.
Do like negative 100 all the way up to,
It's gonna be, yeah, it's gonna keep
'cause that,
subtracting more and more.
that piece is still part of the if statement. If you were to put it into an else statement, then yes. Plus, plus, and then it goes to
The problem is this type of thing, it will never make it to positive because we keep subtracting.
But why is it subtracting? It shouldn't be subtracting. If the continue is there. Oh, if it's greater
Because
than
continue is belongs to if and it's never greater than 0. Right.
So if you said if x is less than 10, continue, it would run up to 10 from negative 100.
Mm.
Never mind. Whole different percentages.
All right. I mean, we have about 4 minutes, so but what I want you to know is you probably want to understand the code, because if you don't understand the code, then you probably gonna choose the wrong answer. At least you know what the continue does, right? I mean, we could try to think about the situation that we try to use the continue to. what you need to know, yeah, the break will make you exit, continue will make it keep going. Like it could be this, I think. Think about, we're going to meet 16 times a week, right? I mean, for the semester, right? 16 times. But we're going to continue to meet if you fail to. Correct? So that condition can use to continue to help. Like x starts from, pretty much your attendance start from 0. And if it's less than or equal to 16, we just count it. Like, but if you fail, Boolean fail, if you fail, then we're going to continue to meet again. That makes sense? Okay, and this is pretty much just print go to class, right? I think maybe that's a good example, huh? All right. Then I have to reset my x to 0 too. Alright, I think it's about time. Okay. Like this one, it's only show you, it's going to do one more time since we fail. That's why I go back and do again instead of 16 times, right?